Hello everyone. My name is Jidnasa Patil and my team members are Durvesh Roge and Harsh Singh from TIT. We are going to talk about Apache Flink, which is a powerful framework for real-time stream processing. So what is Apache Flink? Imagine you have a live video streaming platform like YouTube Live and you want to track how many people are watching a particular stream at every second. Instead of waiting for us to analyze data, Apache Flink processes it instantly as it arrives. It is used for real time processing. It can handle data instantly. If something goes wrong, it recovers automatically. Apache Flink is used in many real world applications where data needs to be processed instantly. Let's break down three common use cases in simple terms. Real time fraud detection. Imagine you have a banking app that monitors transactions. If someone suddenly spends a huge amount in another country, it could be fraud. Flink can analyze transactions in real time, detect unusual spending patterns, send alerts immediately. Second is real time analytics. Companies need to analyze users' behavior instantly to improve their services. For example, an e commerce website like Amazon, Flipkart can track which products are trending right now, show personalized recommendations immediately, adjust discounts dynamically based on demand. Third is event stream processing. This means handling continuous flows of data instead of waiting for a full data set. For example, in a food delivery app like Zomato or Swiggy, Flink can track orders in real time, estimate delivery time based on traffic and weather, update users instantly if there is a delay. Instead of processing orders in batches, Flink can update the system every second to provide accurate and real time tracking.
Flink core architecture. Apache Flink is designed for real-time, distributed, and fault-tolerant stream processing. It ensures high performance and scalability, making it ideal for handling continuous data stream efficiently. Flink architecture consists of three key components. First, Job Manager. The Job Manager is the brain of Flink, responsible for coordinating job execution. It plays a critical role in managing resources and ensuring both smooth processing. The key responsibilities of job manager are job scheduling, breaks into smaller tasks and assign them to task managers. Task coordination ensures tasks execute in the correct order, managing dependencies. Resource management optimize resource allocation for high efficiency. And fault tolerance detects failures and then tasks while preserving state. The second is the task manager. The task manager executes tasks assigned by the job manager. It acts as a worker node in a Flink cluster, handling computation and data management. The key responsibilities of the task manager are task execution, second, memory management, and third, state handling, and also data exchange, which communicates with other task manager to ensure smooth data flow. Multiple task managers work together, enabling scalability and fault tolerance in large-scale real-time application. The third is the data flow. The Flink processes data as a continuous flow, ensuring real-time insights and responsiveness. The flow consists of source. The source injects data from external sources like Kafka, databases, or IoT devices. The second is the processing operators that transform data through filtering, mapping, aggregating, and windowing. Third is the stateful processing, which maintains intermediate results to ensure data consistency. The fourth is the sync, outputs the processed data to store dashboard or other systems. The key features of Apache Flink. First is the windowing. Streaming data is continuous, so Flink groups events into windows for real-time analytics. Different windowing techniques includes the tumbling windows, that is a fixed size window that do not overlap. Second is the sliding windows, overlapping windows that update at regular intervals. Third is the session windows. Dynamic windows based on user activity closing after inactivity. Its example is tracking the number of clicks on a product every 10 minutes in a e-commerce app. Second is the state management. Flink provides powerful state management, allowing it to track and store past data across different processing stages. There are two types of state, that is keyed state and operator state. In keyed state stores data per entity, and in operator state maintains application wide state for aggregating and analytics. Its example is in fraud detection, Flink tracks transaction history to flag suspicious activity in real time. Third is the fault tolerance, ensuring reliability. Flink is built with fault tolerance, ensuring no data loss and quick recovery from failures. In this, there are 2 points, that is checkpointing and exactly once processing. In checkpointing, periodically saves job progress, allowing Flink to restart from the last saved state, and in exactly once processing guarantees each event is processed only once, even in case of failures. Example, in IoT based monitoring, Flink ensures real time updates without losing sensor data, even if a system crash occurs. The real world success of Flink. Flink is used across industries to process real time data efficiently. Fraud detection. Bank uses Flink to detect fraudulent transaction instantly, minimizing financial losses. Real time analytics. E-commerce platforms analyze customer behavior in real time to personalize recommendation. Event stream processing. IoT platforms track sensor data, enabling real-time monitoring, anomaly detection, and predictive maintenance.
So now uh, there is a small example of Apache Flink application. Okay, so we have passed some object as name as a word count. Okay, so we have passed some values which includes text counts, environments. Okay, so there is some variable which has to be passed in the value so that it can be implemented on the output side. Okay, so now I would like to talk about Apache Flink versus the other competition in the market. Okay, so basically when the feature comes like real time processing, fault tolerance, state management, or scalability, Apache Flinks always stands as a outdated, not basically outdated. Okay, Apache Flink always runs smoothly, as we all know. The real-time processing of Apache Flink is excellent. Okay, also the scalability of Apache Flink is excellent. When in it we see between the Apache Flink versus other competitor like Kafka Streams, Spark Streaming, it has very low scalability. Like we can only compare with Apache Flink. Apache Flink can work as a high scalability product also. It can also run various application in market, which is very efficient for all the company members. Okay, so that should be also the future trends of Apache Flink. Okay, when we talk about the future trends, so basically machine learning is the future trends of Apache Flink. Okay, so in machine learning, Apache Flink is a powerful real-time machine, as you all know. Okay, so when it comes for Apache Flink, we can also enable continuous learning and adaptation because it gives the dynamic environment for us to learn or to gain knowledge about any particular field. Okay, also it is serverless Flink. Serverless, Apache Flink offers uh, by cloud providers. Okay, AWS, Kinesis, Data Analytics, GCP Data Flow. Also, we can also pay as we can go by various pricing models for real-time processing. If we want to do the real-time processing for any application or any runtime product which we want to run in the market, so we can only pay for that also. Okay, so also the user experience is very simplified, and it also adopts the SQL adaptation. Okay, so Flink SQL will continue to gain popularity as in streaming jobs. Okay, so more low code also is there, which is very accessible in Apache Flink to non-experts, which is non-expert in tools like various other tools in the market. Okay, so it also has strengths in edge computing and IoT application. uh, Basically it integrates with the 5G networks or ultra low latency processing. Okay, so real time anomaly detection is also there, which includes in the industrial IoT applications. We can see the various future trends in Apache Flink also. Okay, so also when it comes for the security and also the government enhancement. Okay, so better data lineages is also there, which gives a power value to Apache Flink. It has various improved access control, multiple tenancy, which has to be cleared for any security purpose. So this was a short introduction or short uh, brief about what is Apache Flink, what is to be included in the market, what is a basic example of application which has to be needed. Also, there are a few future trends of Apache Flink, which is going to be tremendous in the market. Okay. So, looking forward, I would like to conclude my brief idea about Apache Flink. As I have said also, Apache Flink has established a leading real-time stream experience which enables to process and enlarge a large-scale data, which gives us the ununified batch and streaming processing capabilities. Okay, it is very powerful choice for modern data-driven application. Okay, so Apache Flink is expected to see a greater adaptation in AML, also cloud computing, also edge computing, which improves like ease to use, scalability and security. So thank you